This is HC3. It's our honors review for the end of the year. First problem is an algebraic equation. We have variables on both sides, which means we might end up with an identity or an empty set problem. I'm going to start off by doing leave change opposite. Then I'm going to do distributive property and combine like terms on each side. The first side is already simplified. Second side I need to do distributive property, which would give me 30. And which will also give me a negative 3k, and I'll put that negative 3k with a 2k to make it negative k. Now I have variables on both sides. The coefficients don't match, so that means we're going to get an answer. Let me add 7k to both sides to get them all the k's on one side. I'm left with 14 equals 6k plus 30. Now remember, they've done the problem, so we're undoing it. So they took it times 6 and added 30. We're going to subtract 30, which gets us negative 16, and these cancel out. Divide by 6. That's one negative in a division problem, so your answer is going to be negative with 4 remainders, so negative 2 and 4/6, or negative 2 and 2/3. Second problem is similar. Variables on both sides. No minuses, so I won't have to do any leave change opposite. Let me go ahead and do the distributive property, though. I get 32y plus 20. Over here I get 30y plus 20, and then I add that 2y to that 30y, and I get 32y plus 20. Well, the coefficients match this time, so we're going to have one of the special things, either an identity or empty set. So we go on and we check the constants. 20 matches 20. These two are the exact same thing. This is what we consider an identity property. Okay, they're the exact same thing, so we have infinitely many solutions for why we can put in anything and it will be true because we're doing the exact same math to both sides. And so we would enter in 100 for our answer. Third one, we're looking for the length of a leg of a right triangle. So we're going to have to use Pythagorean theorem, which of course states a squared plus b squared equals c squared. C squared being the hypotenuse. So let me put these in here. We know that c squared is the 20 squared. 17 squared plus b squared equals 20 squared. So I would, of course, work this out, getting 400 and 289. Now we're in a two-step algebraic equation, so I subtract 289 from both sides, which gets me 111 equals b squared. How do I do a squared sign? I do the square root. So now I'm going to get b is equal to 10.53, so we're going to round it to 10.5. Now again, when you do a square root, you could have a positive or a negative answer, but in this application, a negative answer does not make sense. Number 4 asks about solving for f. What we need to remember is that the sum of the interior angles of a triangle, so that angle plus that angle plus that angle every time is 180 degrees. So I have a 90 and a 37, which is 127. And then I have one that they consider 4f. So I know that if I add 4f and 127, I get 180 degrees. So we solve by undoing. I have 4f equals 53, so I divide by 4, and I get 13.25 is what f should be. And then I round it to the nearest tenth, so f we're going to put down as our answer 13.3. All right, number 5, we're going to simplify this thing. I a lot of times put down 2 or 3 fraction bars. We'll do this one piece at a time. So this would be 8 to the negative 5th, which I'm going to go ahead and write on the bottom as an 8 to the positive 5th. Remember, negative exponents move things from top to bottom or bottom to top. We have k to the negative 15th, so it's going to go to the bottom as a k to the positive 15th. We have n to the negative 5th, so it moves to the bottom as n to the positive 5th. And then we have a negative times a negative power, so that's going to be a positive 10th, so we have d to the 10th power. All right, let's go to the bottom. I have 8 to the 28th. That stays on the bottom because it's a positive power. I have a k to the negative 20th, which means it moves up to the top. I have k to the, or n to the 16th, excuse me. It stays on the bottom. And I have d to the negative 32nd, so it moves to the top. Now I'm going to start combining stuff. So I notice that I have 32 d's and 10 d's on the top, which makes d to the 42nd. I notice that I have 8 to the 5th and 8 to the 28th on the bottom, so I'm going to add those together and get 8 to the 33rd. I notice I have an n to the 5th on the bottom and n to the 16th on the bottom, so I'm going to add those together and get n to the 21st. And then if I have k's on top and k's on bottom, remember, they cancel each other out somewhat. So 15 of these k's down here are going to knock out 15 of these k's up here. We'll be left with 5 k's up there. So in the end, I didn't need that last one. Our answer is k to the 5th, d to the 42nd, over 8 to the 33rd, n to the 21st power. All right, the last problem is surface area of a cylinder. To review, cylinders and prisms are the same thing as far as the formula goes. To find the surface area, remember that there are 2 bases, so we need the area of 2 bases. Plus, remember if I drew this out, if I split it and drew it out, it would look like this. I'd have a circle that's on the top and a circle that's on the bottom, and then I'd have this long rectangle. The rectangle is the height of the cylinder, and the distance, the length of the rectangle is the circumference of that circle. So I need to find the circumference. Well, how do I find circumference? You can call it perimeter times height. That's what we do with the excuse me, with a prism instead of a cylinder. But in this one, of course, we have some formulas that go in here. So to find the area of a circle, we do radius squared pi. To find the perimeter of a circle, which is circumference, we take pi times diameter, and then we take it times the height. So this is a formula for surface area, and you could then type that in. You would, of course, put into the radius. Well, the radius would be 7 because the diameter is what we have. 7 squared pi plus pi times diameter times height. Well, I could just take the diameter times the height. Well, the diameter is 14 and the height is 11, so that'd be 154. And then if this is why it's sometimes easy to use pi notation, because if I did this, 7 squared is 49, 2 times 49 is 98, so I'd have 98 pi plus 154 pi, which of course equals 252 pi, and now we can just multiply those, which gets our answer of 791.28, and that would be, of course, units squared. And notice I use pi notation. You don't have to use pi notation. You can type that whole thing into your calculator. Just don't make mistakes. Be careful. Number 14 is an easy one. Write it in standard notation. Of course, if you take anything times 10 to the second power, you're really taking it times 100, right? And so we could just say move the decimal 2 places to the right. That's exactly what that stands for. And our answer is 820.1. For 15 and 16, I'm needing to write this standard form equation into slope-intercept form. So to review, slope-intercept form means I want to have the y by itself, and then the x's, and then the constant at the very end, y equals mx plus b. So I need to get rid of this 4x and get it to the other side, so I subtract 4x. If I subtract 4x, I'd be at 3y equals negative 18 minus 4x. Of course, I'm going to do leave change opposite, so I can put these in the correct order. And that would then make it, of course, 3y equals negative 4x plus negative 18, or minus 18, whichever one you want to do. And then I don't want 3y, so I divide by 3. I'm dividing this whole side by 3. This cancels out, and we're left with y equals negative 4/3 x minus 6. So to review, number 15 is the slope, so that's our negative 4/3. And then negative 6 is our y-intercept. For 17 and 18, we're solving a linear system. That means we have 2 lines there. And of course, 2 lines, there's a couple different options. If they're parallel lines with different y-intercepts, there will be no solution, right? If they are the exact same line, so I'm plotting the same line over top of the other line, then you have an identity problem, so we will have infinitely many solutions to that. Or if they have different slopes, they're going to hit at one point, and that one point is the solution for both of those, and so that's our solution to the linear system. You can solve these by graphing them, which is the least efficient way most of the time, especially if they don't hit in a nice even spot. Or you can substitute for a variable that you know, or you can do elimination. This one's kind of set up for substitution because I already have one of them solved for y right here. So I'm going to do that. I'm just going to write the other one 5x minus 2. And where I come to what the y is, I'm going to put what y is worth from the other equation. Y is worth 3x plus 5. And then I go ahead and finish out equals negative 19. And what you notice is we went from having two variables to just one variable. So now I can do all the work to just solve for this variable. So I would distribute. That gets me negative 6x, which goes with my 5x to make it negative x. And negative 2 times 5 is negative 10. So I'm right here. I need to add 10 to get rid of this. So I add 10, and I get an answer of negative 9 is what negative x is. So now I divide by negative 1, divide by negative 1, and x equals 9. Once I know what x is, I already have half of my solution done. I just plug that 9 into one of the equations. So I'm just going to pick this easier equation in my opinion, and I'm going to put y equals 3 and then substitute the 9 that I solved for x, and add in 5. So now I have 3 times 9, which is 27, and 27 plus 5, of course, is 32. That's where that 32 goes, and that is the point where those two lines would meet, is at 932. Now, one thing I would have you do is always substitute that back into that other equation, so the 9 right there for the x and the 32 that right there for the y, and solve. So let me try that. 9 times 5 is 45. Minus 2 times 32, that's 64. So if I subtracted these two, I would get an answer of negative 19, because I'm going to do leaf change opposite. And isn't that what they got on that one? Negative 19. So it does work. Number 19 is asking for the slope of the line. Two ways to find the slope of the line here. You could just count the slope by the rise and the run. So it's rise, which is 1, 2, 3, 4, 5, 6, 7, 8. Up 8, which is positive. And then write 1, 2, 3, 4. If I simplify that, that simplifies to 2. So it's really going up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. That's your slope. The other way is to do it out with the numbers, and so I'm going to take the difference of y over the difference of x and make sure you keep in the same order. So if I take 10 minus 2, then I need to go in that exact same order, so it needs to be 7 minus 3. And 10 minus 2 is 8, and 7 minus 3 is 4. And again, you have the slope of 2. Number 20 and 21 are asking about the x and y intercept. This is what I know so far. I know the slope is 2. I don't know the y-intercept, which is that b. But I do know some points on here, so I know the point 3, 2. So I could just put those in. That means when I have an input of 3, I end up with an output of 2. So now I'm in an algebraic equation that I can solve, so I get 6 right there. Of course, I want to undo that plus 6, so I subtract 6 from both sides. Those cancel out, and I'm left with b is equal to negative 4. b is equal to negative 4. I can then insert that into my equation to get the entire equation, y equals 2x, and now I know the y-intercept is minus 4. That's your answer for number 20, by the way, is minus 4. The last thing that I want to do is I want to then take a moment and find the x-intercept, where it would hit the x-axis. You could just continue to slope down, and maybe it hits in a nice place, but one thing I want you to remember is it hits the x when y is 0. So just plug in 0 for y and solve the equation. So I would add 4 to both sides. Now I'm at 4 equals 2x. So I divide by 2, I divide by 2, those cancel, and I get x equals 2. So when y is 0, I want you to think about that, that's a point. When y is 0, x is 2. And if you were to plot that point, that's the point 2, 0, it's right there, and guess what? If you extended that line, it would hit that point, which is our x-intercept of 2.